Hello, everyone. It's Thursday, which means it's another episode of Simon's Things on Thursdays here on the Redis, Twitch, and YouTube channels. If you are new to this is the show where I generally look at IoT devices or sort of lower level concepts and how that relates to Redis or Redis Stack. So in the past, we've looked at things like Bloom filters. We look at streaming data quite a lot, and that's something we'll look at today. And we generally use some microcontrollers and single board computers. So in the past, we've used Raspberry Pis. We use the little Raspberry Pi Pico W here quite a lot because it's pretty cost effective. It has Wi-Fi. You can program it in MicroPython, which makes it pretty accessible. And what's important right now during this sort of ongoing chip shortage situation is you can actually buy them. So they're not that hard to come by. So I'll be looking at that again today. We'll be using the Pi Pico as a sort of display for something to do with Redis Streams. And we are going to be looking at streaming data into a Redis stream and then consuming it with what's called a consumer group, which we'll sort of have a look at shortly. But meantime, if you are interested in what we're up to, the best way of chatting with us is go ahead and join our Discord at the link down below there. We have a channel for IoT, so anything related to this show, or love to see your own IoT project or anything you're doing. But we also have channels for everything else. If you're kind of new to Redis or you want to learn some more about it, we have free courses at university.redis.com. So you can go ahead there, sign up for free. They're all online, mostly video or text-based courses with some exercises and homework that you can do. And you can earn a certificate of completion on those and put it on your LinkedIn. And yeah, these videos live sort of ephemerally for a few days on Twitch. So twitch.tv/RedisInc. That's also subscribe to us if you want to get notified when we go live again. There's currently a few members of the team doing live streams, team streams. So there's myself on Thursdays. Generally, you'll also find Justin on Mondays. He's working with a large data set about birds and the JSON capabilities of Redis. And Savannah on Tuesdays has been working with, I believe, the Twitter API and some sentiment analysis in Python. So if you want to see different things, we have those shows. You can also find us on YouTube. Subscribe down there. And again, you can get notifications whenever we go live or publish something. And then finally, we have a schedule page that if you want to see what's going on for a given week, you can find us there, and that sort of consolidates everything that we have. So I think that's like enough introductory stuff. I'm here in Nottingham in England. It's the middle of the morning, so slightly different time of the day from a lot of our US-based streaming. So hello to folks who are out there at this time of the day, or if you're watching us later on YouTube. It's been quite a good start to the day here. We had a bit of rain and then we had a double rainbow, so it can't be all bad. So what I wanted to do was start off with a little bit of an explainer on what Redis streams are, just in case anybody's new to the topic. And then we're going to look at something that was introduced specifically in Redis 7. So we'll see what that is and how it can help us with a problem that you might have when you're working with streams, or rather a need that you might have, not really a problem. So what I'm going to do is go ahead and move some things around and share the desktop. There we go. So first up, what is a Redis stream? So it's a data type in Redis. Redis is a data store and it has different sort of types and they come with behaviors. So for a simple string, you might be able to set it or get it in Redis, or set it and set an expiry and then you've got a cache, or set it if it doesn't already exist, or all sorts of things. Streams are probably the single most complicated data type in Redis. By complicated, I mean they have the most commands, the most things you can do with them, the most behaviors. There's a lot going on. So there's a couple of ways you can think of a stream. So one would be like an append-only log. So once you put something in a stream, that thing is actually immutable. You can't change it anymore. You can remove it, but you can't change the values that were in there. And it will be kept ordered. and it will be kept ordered by ID. And normally the ID that you use with a stream is a timestamp. So what we can see here on the screen is 3 stream entries that were put in there by an architectural component we'll call a producer, so something that produces events and drops them in the stream. And those 3 different entries have timestamps. And what we're doing with this example is you'll see the entry IDs are a timestamp dash a sequence number. So that one in the middle, we have -1. Otherwise, its ID is the same as the one over to the right. And the reason for that is Redis can generate these millisecond timestamps for us when we put things in the stream. And it's also fast enough to be able to receive stream entries at a rate of more than 1 millisecond. So if that happens, it uses an incrementing sequence number to make sure that things land in the right order. So the stream is ordered and the entries are immutable. So what goes in the entries? Well, basically anything we like. So here I've got 3 entries up on the screen. They are all sets of name value pairs. So if you're familiar with Redis, this kind of looks like a Redis hash. It isn't, it's a stream entry, but the mechanic is similar. So I have something called room, and I've got a room number, and I have something called job, and then we have a string. So in this case, we're modeling a hotel front desk or self-service room service type scenario, whereby a producer would be someone on the front desk, or it might be you with your smart TV in the room, or a telephone touchpad system, or whatever they've given you. And you can say, hey, I'm in room 199 and I'd like a taxi, please. Or I'd like extra towels and I'm in 238. Or I'm in 324 and I would like some cleaning done. If you'd like to see this use case sort of played out a little bit more, go check out the past streams on YouTube. I have a playlist for me, and in there you'll find a Node-RED project that I did, where we look at building out a system to essentially manage the doing of these jobs. So, people produce these jobs and consumers, or hotel staff in this case are the consumers, have to actually do the jobs. So one way you can think of the stream would be as this sort of append-only log of what happened. Another way, and this diagram I think kind of shows that reasonably well, is you can think of it as a sort of buffer or queue. So imagine that the producer is popping things onto the stream, and it's really not interested in whether anybody's consuming it or what the consumers are or how many of them there are or what they do with the data. Its job is just to produce stuff. So off it goes and produces stuff. And it's completely like architecturally decoupled from the consumer. So they're only talking to each other through this Redis stream data structure. So as we'll see in a bit, the producer could be written in one programming language, could be Python, JavaScript, Java, whatever, C#. And the consumer could be written in another one. So that could be Java, Ruby, Go, whatever. It really doesn't matter. And the sort of shared interface they have is this stream inside Redis. They both know about this stream's key in Redis, which we've called jobs. So all of our entries live in a stream called jobs. And that's kind of all they need to know about each other. So that's the use case we're going to use here. So we're going to use a stream as a sort of buffer between 2 things that work at different rates. And the new feature we're going to look at is the ability to determine how far behind on what's being produced those consumers are. So when you're working with streams, you want to have a sort of throughput rate, and sometimes you're going to have a situation whereby things get created faster than that throughput rate. So you might need to scale up by adding more consumers. Other times things will be quiet. So you might want to scale down by removing some consumers. So you don't have a lot of sort of resource sitting around waiting. So this is a sort of common microservices or just general architectural pattern. You might, as things start to pile up in the stream, add more instances of a consumer, and they need to work together to collaboratively process the stream. And we'll look at how that works. And what we're going to look at is the ability to determine what the consumer lag is, or the consumer group lag is. And we're going to try and render that out in a fun way with a little Raspberry Pi. So if I go to the next slide here, so what you'll see is when we want to add something to a stream, we use a Redis command called xadd, and we give it the key name of the stream, so jobs there. And then we have this asterisk thing, and that's an ID. So if I'm using asterisk, I'm telling Redis, do the thing with the timestamps for me. Use the server's timestamp and create an ID for me that's timestamped. The rest of the command is just the name value pairs that we want to store against that ID in the stream entry. So what happens here is it'll go away and drop that into a stream. Part of the fun with working with Redis is it makes your life easy. So what if that stream doesn't exist? How do you like dimension or declare a stream? You don't have to. Just add something to a stream that doesn't exist, and it's going to create it for you. Another thing that I should point out here is that you don't have a fixed schema in these stream entries. So it's kind of up to your application to be able to cope with parsing out whatever's in there. So here I've got one entry that talks about a room and a job, but the next entry might talk about something completely different, like a location and the weather. So it might have, a lat and a long field, and then a temperature field and a humidity field. Is that a good use of a single stream? No, not really, but you can mix different types of things in there. So if you're doing that, you might want to have a known key that tells you, what type of entry it is. Your application will know what name value pairs to expect based on that. So here we're going to make it nice and easy. We're going to stick to, we're talking about rooms and jobs because we're a hotel and we want to have people directed to certain rooms to do jobs that are requested by our guests. So this is how we add a new entry. Then we're going to look at how we can read entries from a stream. And I said before that streams are sort of a buffer, a queue, and an append-only log. So there's like two sort of read mechanics that reflect those two different use cases. So the first one up here, we're using a command called xrange, and that gives us all of the things that were put in the stream between a pair of IDs. So if we have a lower ID and an upper bound ID, we can ask the stream what was put in you between those two IDs. And given that the IDs are by default timestamps, we've essentially got the ability to say, hey, what happened at a specific period in time? So here I'm saying I want the range of things that happened in the job stream between these 2 millisecond timestamps, and that matches to those 2 entries. So that would get me those 2 entries. So if I was looking at this as like an append-only log and I was scrolling the log, or I wanted to filter by timestamp, we've got that set up. I can also do something slightly different. So if I'm treating this more as a buffer, or I want to process it in order, and I don't, have a particular time frame in mind, I just want, give me the next one, or give me the next 2, or give me the next however many, I can use a command called xread. So what xread does is we tell it how many messages we want, and it can read from multiple streams at the same time for sort of network efficiency. So we tell it for each stream, the name of the stream, and then we tell it the ID of the last message that we know about in that stream. So over there on the right, I'm starting with ID 0, which is like the lowest possible ID you can put in a stream. So basically saying, let's start at the beginning and give me 2 things, and I'll get those 2 entries. So I'll get the one ending in 1950, which is cleaning for 324. And I'll get the one ending in 1951, which is extra towels for 238. So what you'll see here is we get those 2 entries back. And then what I need to do as the application or the person querying the stream is remember the entry of the last message that I got back. So like the highest entry that I've seen so far. So I then feed that into another xread command. So you see down the bottom, if I put in the entry 195-1, then I will get the next 2 that are whose entries IDs are bigger than that one. So we're basically saying, okay, I've read everything up to the period in time of 195-1. Now I want whatever the next two things are. And I don't need to know, what sort of time period they occurred in. It could be like it could be that they occurred within a minute of 195-1. It could be that they occurred like 2 days later. It doesn't matter. So in this way, I can move through the stream. And one thing that is really important to sort of get into your head, and I'll probably say this multiple times because I always do, is when you are treating a stream like a buffer or a queue like this, reading isn't removing. So we're not changing the state of the stream here. So if somebody else comes along and they do X read count 2 streams jobs 0, they'll get 1950 and 1951 as well. So this is good when you've got multiple different types of consumer that need to pull through the stream and do different things. So maybe one of these is like the cleaning manager or the staff manager who's pulling these jobs and saying, okay, I'll give that to Simon to do, and I'll give this to Eleanor to do, and somebody else can do this third one. And then maybe another consumer going through this stream is the one that automates the billing for these things. So we might say that, like, a cab gets associated with, there's like a 10 currency units tip or something that the concierge gets for every time you order a cab. So put that on room 199's bill automatically. So we might have different consumers that want to process this stream, and that's fine. What we also might want is, say we wanted to allow processing of this stream by the people who do these jobs directly. So there's more than one of those, but let's assume that like any person can do any of these jobs. So we have a pool of people and they all want to read through this stream and do the jobs. But in this model, if they all started with ID 0, they'd all get that first job for go clean 324, and they'd all run off and clean 324. And then 324 will be really clean, or they'd get there and find someone else was doing it or had already done it. So that's not a very good way of dealing with a pool of resources that can do the same thing. So what we need is some way of processing the stream collaboratively with a pool of resources. So this is where the diagram gets a little bit more complicated. But this is where we introduce consumer groups, and this is kind of like part of the feature that we're going to look at today. So I'll take this from left to right. So firstly, over there on the left, you've got multiple instances of the producer. This is true of any stream situation. So if we back it up to here, we could have had multiple instances of the producer here. They can all just put stuff in the stream. And if we're using the asterisk, so the hey, Redis, you create the ID, it'll figure out the ID and get the order right according to the order of events. So we could have multiple people working on the front desk there and people putting in jobs through their smart TVs or their phone systems or whatever else we've given the guests. So that producer can scale to multiple instances. They're all independent of each other. They don't need to know anything about anything else. Their role is to just put jobs on the stream. And then over down the bottom right, we have consumers operating in the way that we looked at already. So they would be using XRead and XRange, and they would be doing things like, one might be showing a dashboard of like, here's the jobs that have come up in the last 10 minutes or today or last week or whatever time period it's looking at. The other one might be, as I say, doing billing or data warehouse or something. Those two are completely independent of each other. They both need a view of the entire stream to do their jobs. So they operate completely independently and just run through the stream like almost it's a batch process. So we're not too worried about scaling those. However, what we are worried about here is managing customer experience. So if we've got a lot of jobs going onto our stream, and we've got a pool of staff that can do those jobs, we want those staff to be assigned jobs in a way that respects how many different staff there are, and so that each staff member doesn't get the same job. So they don't all run off to 324 to do cleaning, or one of them goes to 324 to do cleaning and then two of them take extra towels to 238. Yeah, we want the first one to do cleaning in 324, the second one to do extra towels in 238, and the third one to go get that taxi for 199. So we do that in Redis Streams using something called consumer groups. And what that basically means is we use a command called xread group, and we say that I want to read through the stream and I want to be given the next entry in the stream that hasn't already been given to somebody in my group. So we have a group, we have to identify it as a group. So we might have a group called staff or cleaners or concierge or what have you. And any consumer that identifies as that a member of that group can be given a job, but it'll be given the next job that no other consumer in that group has yet received. And then there's an additional mechanic that's not too relevant to what we're going to do today. So with xread group, Redis tracks who's been allocated what job so that the next person in the consumer group gets a different one. There's a command called xac that basically allows us to say, okay, I finished this job with ID whatever. Consider that one done. And the reason why that's there is in the case where you give, say, that cleaning job 1950 to, say, staff member 1, and staff member 1 goes to start doing it and they have an accident on the way or they get sick or something and they're unable to complete it, there are mechanics to query the state of the consumer group and say, okay, well, how many jobs have been allocated to people or to consumers, but not yet acknowledged as complete? And you could then go into the stream status and take that job from staff member 1 and either put it back in the pool or explicitly give it to another staff member in the group. So there's mechanics for that. That's a little bit complicated for today. But if you were to go to university.redis.com, we have a course called, appropriately, Redis Streams that does cover this in quite some detail. So what we're going to look at today is we're going to set up some code that runs this, and then we're going to look at the state of the stream while it's running. Because imagine you're the sort of staff manager in this scenario, or if this is something that's running something else, like this is a stream of entries for credit card transactions, and you're running fraud processing against them, and you need some sort of throughput because it needs to be pretty real time because the customers may be waiting there at a card terminal for a response from you. Then you're going to need to want to know how many staff or how many resources to put on consuming the stream. And with a lot of things, you don't want to get it wrong either way. You want just enough that you've got that level of throughput. You don't want too many that you have redundancies or people underworked or processes that are costing you compute time but not doing anything a lot of the time. So you need to scale up and scale down. And we'll look at a mechanic in Redis 7 that allows you to sort of look at the backlog here. So basically, how many things have been put on the stream that the consumer group hasn't yet read? So how far behind are the staff with doing the jobs? In previous versions of Redis, you kind of had to do the math and do this yourself. In Redis 7, it's built in. So that's what we'll look at. What I was going to do first was set up from a blank database. I've got some code that performs each of these roles here, a consumer group and a producer, and we'll let it run and we'll just look at what's going on for a moment. So with that said, I think we can get rid of slides and actually do something. So I've got some code here. It's from a workshop. It's from a workshop that I do periodically on Redis Streams. So if you want to try this out yourself, you can go there, and there is here. Go there on GitHub and get this code and try it out. It is fairly well documented, and there's also an option to run it completely in the cloud if you want to, so you don't need even a Redis instance. I'm going to run it locally, and we're going to maybe make some changes to it. So let's see. So I think what we're going to need now is a terminal. So let us do that. So I've got this repo checked out here. Let's make this a little bit bigger. And let's also have a look at some Redis stuff. So I'm going to use Redis Insight, which is a graphical user interface for connecting to Redis. And I've got it set up for a few Redis instances, but I need to add a new one because this one is somewhere else on the network. So I think it is at 192.168.4.22, and it's there. And I'm going to call it Redis 7, and it's actually on my iMac, so we'll call it that. And I've not set a username or a password, so hopefully we can connect to that. So there we go. I've now got Redis 7 iMac, and let's connect to that. And it's a completely empty database right now, so there's no keys. This is the key viewer. Absolutely nothing there. And if we go into the CLI here, we can execute Redis commands. So I can do, for example, info server, and you'll see I've got Redis 707. So what we're going to play with today, the sort of lag monitoring feature does require Redis 7. So if you've got an older version of Redis, then you can get 7, or you can try this out with Docker, or just go use the online method in the GitHub repo, because it will figure all of that out for you. So we'll keep this CLI around because it might be useful. CLIs? Yeah. CLS used to be clear screen in like Sinclair Basic. I don't know why I'm reverting to that. That's from the 80s. Right. Anyways, so we've got this repo. I probably need to make a little change to it, because here is our producer. So the thing that's going to put these jobs on the queue. We'll see if we can upscale that a little bit. And what this is going to do is, it's Python. It's an arbitrary choice. It could have been written in anything. It's going to use a stream key called jobs. So like we saw on the slide, it's going to have these different sorts of job types, and it's going to connect to Redis. And it's basically going to just randomly create a dict that we'll call a job, and it's going to have a room and a job. So those main value pairs that you saw on the slide, we're going to add it to the stream, and we're not going to specify an ID. That means Redis is going to do that for us. So we'll get an ID back, and then we're just going to output which ID we created and print the dict. And then we're going to go to sleep for between 5 and 10 seconds. So basically, this is just going to create random jobs every 5 to 10 seconds. And what I need to change briefly is this here. So this is connecting to Redis on my local machine, the machine I'm running on. I want to connect to my other machine that is running Redis 7. So I think all I need to do is host is 192.168.4.22. And that should be it. We'll save that out, and let's see if we can set this off and running. Right, so we want to go cd producer, and I'm using a virtual environment in Python to keep all my dependencies sort of local to this folder and not mess up my global Python environment. I have got requirements for this project are basically just Redis, which is Redis Pi, the client for Python. Everything else comes with that. And I should have installed those already. So we should be able to do Python producer.py, and off it goes. So it's created a job, and there's the timestamp of that, and it wants a taxi in room 320. And it's created another one, extra towels for 192. So what we can now do is go back to Insight here and refresh this, and you'll see that I've now got a single key called jobs. And if we make this wider, we'll get a better view. There we go. If I click on that key, you will see that it's rendering the stream out nicely for us. So we've got all of these jobs, and I can even turn on this auto refresh. And what it will do is, there we go, every time a new job gets created, so 280 extra towels just got created down here. Let's watch for one more while I take a coffee break. 168 extra pillows. So 168 extra pillows. So as we can see, it's off creating jobs, and we're looking at them here in Insight. So that seems to be working nicely. We'll leave this running for a while and have it create some jobs in the background. So let's create a new window and see if it goes. No, it doesn't. What do I want? Redis Streams Hotel Jobs, I've called it. I've got so many repos to begin with Redis. There we go. We've got the producer running here. What we should do now is run some sort of consumer. So read through the stream, right? So we want somebody to go look at these jobs. So if we come back to the repo here and open the Explorer back up, I've got a couple of sorts of consumer going on here. So I've got a consumer folder, and in there we've got consumer.py. And let's have a quick look at what that does. So this again is going to work with the job stream keys. This is the only key that we've got in Redis anyway. I need to hook it up to the right host for what we're doing today. 22. And we need to get rid of that. So that's going to hook it up to our right host. And then let's just take a quick look at what this is doing. So when it first runs, the last job that it's seen, we're going to say has the ID of 0. So that's the lowest possible ID. So we're going to start at the start of the stream. So whatever the oldest thing in there is. We're then going to go into a loop forever. So this code will basically be forever doing jobs until there are no more to do. And we'll see how that works. And then we're going to call this xread command. And we're going to say for the stream jobs, we want you to read from whatever the last ID is. I want one job back at a time because I can only do one job at a time. And this block equals 5,000 basically means and block for 5 seconds if there's nothing in the stream whose ID is bigger than the one that I'm giving you. So basically, when I get to the end of the stream, I'm going to just like sit there and poll it and wait for 5 seconds and see what comes back. And if what comes back is basically an empty response, then I've caught up and I can go and have a coffee, sit down, have a cup of tea, eat a Kit Kat, whatever. There's no jobs to do. Otherwise, if something does come back, then we sort of basically parse out the data structure that we get back and get information about the job. And then we pretend to do it by going to sleep for a random number of seconds. And then what we do is we update that variable last job ID to be the ID of the job that we just did. So that's how we're going to walk through the stream. So next time around, we're going to pass in a different value than 0. I'm going to iterate through the stream that way. So this here has still been making values. And if we go over here, we can see it's made 32 of them so far. So we have 32 job backlog. So if I now go to my consumer here, and let's do cd consumer, and same deal with the virtual environment. Let's activate that, and let's do Python consumer.py. Off it goes, and you can see which jobs it's getting back. It's just dumping out the data structure. So for the jobs, that's the name of the stream there, jobs, and then it got this one thing back, which is an ID and a dict of the name value pairs. So it's off doing these, and eventually it might catch up. So this might create jobs faster than this can do it. And if we stop this and no new jobs get created, then of course this consumer will eventually catch up. And I said I would repeat myself. So what's happening here is every time a job gets done, you might be tempted to think that job's popped off of a queue. especially, or pops off of the stream. So especially if you're used to using Redis lists as queues, where you use commands like brpop, that would actually remove it from the data structure. This doesn't, because it's a stream, so multiple consumers may want to consume it for different reasons. And there are methods for, there's an xdel command that would delete an entry by ID, and there's an trim command that would delete entries that haven't, up to a certain ID, or you can trim the stream to be a certain length. So we could say just trim it so that I've only got 10 left, for example, and it would keep the newest 10. Or we could say trim it up to like this morning at 11:12 a.m. and we could do it that way. So we're not trimming our stream in this example. So we actually have got a runaway data structure here. But in the real world, once we've done all the processing, we'd like keep some sort of tally of where we're up to and clean it up periodically. So that's our stream. We're reading from it. Let's go check out what our consumer is doing. It's still doing jobs. So it's got to this point in time, whatever 7914 represents. Don't know if we can see that in here. Yeah, there it is, 7914. So it's got a few more to do. And then it's basically going to hit that point of, oh, I'm done now. I've been through the whole stream. So this is great. And this is like a single instance of the consumer. So imagine we have, one staff member that can do this job. They're the only person that's going to do the job. That's not very realistic in the real world. So let's see if this is caught up yet. Looks like it's taking its time now. There we go. So it's checking for jobs. There's nothing to do. So it's gone to sleep for 5 seconds. It's now blocking, running a blocking read to Redis. And yeah, Redis has got nothing new for it. It's caught up. So yet again, I just want to show this. If I refresh this stream, still got 40 entries. So what we're looking for is entries that are newer than this 9891. And there aren't any, which is why we stopped. So if I then leave this consumer running here and put the producer back on, you'll see as soon as this created that job 2402, this picked it up. It's done it, and now it's waiting again. There's nothing to do, but a new job got created over there on the left. So when it comes back from its sleep, it'll pick that up and do it. And now they're kind of more in sync with each other. But if we left this running long enough, you would probably expect that the jobs will get produced faster than a single consumer can handle them. So let's stop this again and figure out how we might want to deal with that. So I said when we looked at the slides, and we won't go back to the slides because we've had enough slides for one day, that there's another sort of consumer available here. So this process here kind of works on its own. It just reads through the stream and does the things. And like, sure, we could get clever and we could like implement some sort of multi-threading in here to say, go off and do that job in another thread and then just grab another one from Redis. But then we're building out all of this logic to manage that sort of stuff when the database can do it for us. So what we want to look at now is the consumer groups. So let's get rid of this. And we've got another sort of consumer inside this project here called consumer group. And this one purely for variation. So I've got something different to talk about. And also so this project resonates with different groups of developers. This is in Node.js. So again, completely arbitrary choice. We could have written all of these components in pretty much any language you can imagine, because there's Redis clients for most popular languages. So we could have just randomly gone, you know what, we'll use Java, Go, and C#. I'm not particularly good at those things, so I use Python and Node.js. But we could have written all of this in Node, or we could have written some of it in Python. It literally doesn't matter. What matters is these things are talking to each other through the stream and the stream only. So they don't need to worry about how languages represent data types or communications protocols between processes or anything like that. Redis is taking all of that on for us. So I've got a Node.js application. So we've got, as you might expect, a package JSON. we don't have a script there to run it, but that's okay. We can figure that out. And we have a single dependency, so Redis, which is a Redis client called Node Redis. That is the predominant client for working with Redis in Node.js. So we've got that. I've already gone ahead and installed that, but basically just do npm install like you would with any other Node project. And then let's go and have a look at how this works. So over here we have, I was kind to myself. I put a usage message in. So we have a process that takes some arguments. So you're going to call this with a consumer name. So now we're working with a consumer group. We have more than one consumer. So we need to identify the consumer with a couple of things. We need to identify them with a group name. So that might be a role. So like, I might be staff, or I might be concierge, or what have you. And then within that role, I have like a unique identifier that could be my employee number, or it could be my name. So I could be staff Simon, or what have you. And we're going to use that staff group ID to say the stream needs to be split out between everybody in this group somehow so that they can collaboratively process it. And we're going to use the consumer names to identify individual consumers. So we can say, oh, Simon's currently got this job, and James has currently got that job, and Tracy's currently got this other job, and so forth. So we can basically then start up as many instances of this process as we want, give them different consumer names, and build a pool of resources to do the jobs. So roughly, this is going to do the same thing. It's going to pull the next job off of the queue or the stream. In this case, we're not directly going to work with stream IDs because we don't know what the next one is, because other processes in our group might have taken them. So we're going to let Redis manage that for us and see how that works. But once we've been given a job, we're going to pretend to do it. So we have this random sleep process that it's a little bit convoluted in Node because Node is non-blocking, but basically we just return a set timeout as a promise and await it. So we sit around doing nothing. We're going to work with this one stream called jobs. We're going to have a consumer group name called staff. And we're going to have a consumer name that we pull off of the arguments to the process. So when we start this, we'll do node consumer group Simon, node consumer group Jill, whatever else, and have some different consumers. So we are going to create a Redis client, connect to Redis. Going to need to come back and change that so that it talks to 192.168.4.22. My Redis today. And what we're going to do when we start this is, unusually for Redis, we do need to create a consumer group in Redis. So we need to tell Redis there will be this distinct group of consumers, and it's going to be called whatever we want to call it. So we're calling it the value of this here, which is staff. And why we have this is because we could have multiple different groups, and we need to be able to track them differently. And also we need to tell Redis where in the stream should that group start reading from. So the only time I'm going to use an explicit ID here is here. So when I create this consumer group, I'm saying anybody that identifies as staff, so staff Simon, staff Jill, staff whomever, they need to be in this group, and this group needs to have started at the beginning of the stream. And then just in case we fire up the staff before we've actually created a stream, I am passing in this extra parameter that says X group actually needs the stream to exist. So it'll create a blank stream for us if necessary. And we're going to run this every single time we start. It's going to throw an exception if the consumer group already exists. We don't really care about that. So we just want to make sure it is created at least, well, it's created exactly once. So the first time we run it, it's going to do this little bit of admin, create a consumer group for us. Otherwise, it's just going to skip that. then what we're going to see is it starts to look a bit like the other consumer. So we have a while true loop here, so we're always going to be doing something. And then inside here, we're going to use this xread group command. So before we used xread and we gave it the ID of whatever the message we received last was, and it gave us back any message that was bigger than that. So the next one along. We're going to use xread group. We're going to give it a consumer name. We're going to say, I am acting as a member of this group. And my name is Simon, or whatever we configure it to be. So staff Simon. And then in here, we can provide an array of streams and IDs. So we could read from multiple streams at once, because this is a blocking command. So if we're going to block, we might as well get a lot of value out of it. We're just reading from one stream here. And we're saying, I want to read from my jobs stream. And here, I said I wouldn't use explicit IDs anymore. So I can't say anymore, well, what ID, the ID that I saw last as this particular consumer, Simon, that isn't necessarily the biggest ID that the consumer group has seen, because while Simon was off doing a job somewhere in the hotel, somebody might have assigned the next jobs in the line to other staff members who are busy doing those. So when I come along, I want to skip those and I want to be told, here's the next one that doesn't already have somebody assigned to it or nobody's seen it. And there's a special ID in Redis Streams for that, which is greater than. So you can basically just say, hey, Redis, give me whatever comes next after the ones that you already assigned to people. So I'm no longer managing the ID inside this, this consumer. So before in the old consumer, I was managing what ID I'd seen and tracking that myself. So I was kind of like responsible for that. This responsibility in a consumer group moves to the database. So Redis is managing it for us. And then similarly to before, I can say how many messages I want. So I can only do one job at a time. So I want one. And how long to wait around if there isn't anything new for me. We'll say 5 seconds. Now, what I'm doing then is when I get the job, I'm just dumping it out into the console. And then similarly to the Python, if there actually was something, we're going to parse out the data structure that we get back. We're going to pretend to do the job by basically falling asleep on the job for a few seconds. And then what's different from the previous consumer is that would be the end of it in the previous consumer, where it's working on its own. We would just then update our last stored ID and just go back to the top of the loop and do xread with that. With xread group, we need to tell Redis that we've actually done the job. And this is so that if we fail to do the job for some reason, or we take too long, or we time out, or something in the data causes this consumer to crash, then Redis knows that that job was kind of seen but not completed. And there are mechanisms for reassigning it to other consumers that we won't go into today. But again, those are in the Streams course over on university.redis.com. So go look at that there if you're interested in that. One day I'll look at sort of non-happy path situations with stream consumers. If there's some data in here that's what's called a poison pill message that just knocks the consumer over because it can't deal with it. Then we need to identify that this consumer is struggling with that message, and maybe it keeps booting up and trying it and failing over and over again. And there are mechanisms for dealing with that, and we should look at those on stream, but that's not today. So basically the takeaway is Redis is managing the IDs, not us, and we need to do this acknowledgement step to tell it, yeah, that one's good. We're finished with it. So what we can do now is go ahead and run this. And if we run a single instance of it, we'll pretty much have the same mechanic as we had before. So one consumer will go through, read all of the messages in the stream, and it will basically be a single thread of processing. So we'll still have this problem of we have got a number of messages in the stream, or they're building up faster than we can tear them down by completing things. So what I do need to do is just go back to here and configure this so we're talking to the right Redis. So I can't remember how to do this in Node Redis, so let's do, let's take a look. And here we go. So this basically just creates a standard client with localhost and 6379. Looks like we can pass it an object with a URL in, and I know we can pass it an object with all the fields broken out as well, but I kind of like this. So because it allows us to configure multiple things if we had a password or a non-standard port or whatever. So I use this one quite a lot, but I have no muscle memory for it. So what we're going to do is that, and then we are going to take that away, and this will be a username and a password. We don't have those, so we don't need that. Our host is going to be my IP address there, and it's actually on the standard normal Redis port, so 6379. Hopefully that'll do. And we now connect to the right Redis database over on my other computer. So let's see what we've got here. We have got in Insight, we've got a stream that has 45 entries in it. So the producer hasn't been running for a while here. We've not generated any new work. The previous consumer doesn't remove these, so we've still got 45 entries. So as far as we're concerned, we can start again and say we've got 45 job backlog to do. We need to work through it. So let's use both of these terminals and come out of the Python environment. And we've got something called consumer group here that we need to look at. And then I think we said we run node consumer group.js, and then we give it a staff member. So let's try that. There we go. So with one staff member on duty, Simon, I'm going to get all of the jobs. So it's going to look like the other system. And I'm getting all of those, but now I'm in a group. So I'm a group of currently there's one staff member on. So if you look at this again, the number of jobs isn't going down, but we're working through them here. But now if we go over to this consumer groups tab, you'll see I have a consumer group staff, and I can click through to that. And you can see there's one consumer on, and I'm just blowing through all the jobs at the minute myself. So I've got one pending job because that's the most I can have, because that's the most I was asking for. And then I haven't been heard from for a little while, and you start to see that we can track what's going on here. So I'm going through all of these jobs. It's going to take me a while. That's not a good customer experience. So what we need to do is fire up a second consumer group, and let's call this second person, I don't know, Alice. So Alice has started work, and now Alice doesn't get the first job in the stream like a normal consumer would, because I've already done some of those and I'm in the same group. So Alice has started kind of where I just ahead of me in the queue, and now we're just like working together and picking things off. So you're just gonna have to trust me on this, that basically an ID that you see on this side will not appear on this side. So if Alice is doing the job, Simon isn't doing it. If Simon's doing the job, Alice isn't doing it. But now we have twice the throughput. So if we go look at Insight here and refresh this, you'll see there's Alice and Simon now in the staff group. And you know, at the summary level here, we have two consumers. So one of the things that we need to try and understand is how to look at how far behind these people are with processing the jobs, because we might want to use that to alter our staffing. So we might like divert more resources into processing the jobs. And then when we're done with it, or when we've got a smaller backlog, we might want to reduce those resources, you know, send them home or put them onto other work or whatever. So how we can do that, and this is a Redis 7 thing, is there's this command xinfo. And what that's going to do is, number one, it's going to look quite small on the stream. So hopefully you can see that. So we're going to do X info. I think it's, you know what, when we don't know, let's look at this. It's almost like I prepared this. So there's an X info groups command. So we're going to ask it about consumer groups, and we just need the stream key. So that's jobs in our case. So, okay, we want X info groups. They don't have to be capitals, but I'm just doing this to make it clearer. So xinfo groups gives us this output here. I can make this bigger. Let's zoom in. It kind of just messes with the key view a bit, but hopefully that's a bit clearer. So what we can see here is xinfo groups jobs gave us the name of a consumer group. So this would work for each consumer group we had if we had other consumers. And you see there's 2 people currently, or 2 consumers currently in that. There's no jobs pending. So that means that nobody's read a job from the stream and not run that exec acknowledgement to say they've finished it yet. So there's no work outstanding. You can see that the last message, or the highest ID that's been delivered to this group, was that one. The group has worked through 45 entries. This entries read field is new to xinfo groups for Redis 7. So if you're using Redis 6 or 5, you won't see that. And then we've got this lag thing here, which is 0. So this tells me we're up to date at the minute. So if we go here, we can see that my consumer instance, the first one, has nothing to do. My consumer instance, the second one, also has nothing to do. So we've caught up with that. We don't have any lag. So if I then do new window, and let's start our producer again. Start the virtual environment for Python, and then do Python producer.py like that. You'll see that I'm creating jobs. And because we're caught up, there's not a lot to do here. So you'll see that my consumers managed to grab both of the jobs so far. There you go, the one, Alice, I think I called the other one Alice, has grabbed this job, and I'm now sitting around with nothing to do. So we've got 2 staff on. This is probably about the right sort of balance. But what I'm going to do now is stop both of those and leave the producer running. And we're going to build up a backlog of jobs. So let's do, we can also run multiple producers. There's no downside to this. So let's assume that there's like more than one person on the front desk. Let's start up a second one of these. So it's off creating more random jobs. So jobs are getting created, and we've got a little bit behind now. So let's restart our consumers. So they're doing the jobs. Now let's go back to Insight and let's rerun this command. And you'll see that we're currently 5 behind. So again, this is new information in Redis 7. So we're now 4 behind, we're catching up a bit. So we can start to use this both to present a visual of how far we are behind, and also maybe to make some decisions. So yeah, we can call this command from a Redis client. So we could write some Python or some Node or something that monitors this number and says if it's been above a certain amount, then raise an alarm somewhere or automatically start another process if you're scaling things in like a cloud environment, or you've got processes that can be scaled like that, or if it's literally people and they're working with handheld devices to tell them what job to do and what the next job is, go get more people working because you've got this backlog. So we've caught up again now. We've got 0 lag. So that's the sort of new and fun thing in here for Redis 7, entries read and lag. So we can see how far behind a given consumer group is. If we have multiple consumer groups, running against this. So imagine we had like staff doing the jobs, and then we had something else like an accounting consumer group where it just collaboratively takes each job and updates the room folio with any charges associated with it. We would expect to see this output twice. So we would see a data structure that has a 2 down here, and it has these 12 items for the other group. Excuse me. And so on for as many groups as we want to do. So what I want to do with this in next week's stream is take this information and kind of do something a little bit more visual with it, because you might be like, hang on, Simon, this has all been database and chalk and talk and programming on laptop. Where's the IoT bit of this? If you're running something like a hotel or any sort of site where people are doing work, it's really useful to have a sort of dashboard or indicator that things are going well or not so well, and people can see that and react to it accordingly and make changes, and then watch how it changes, and then settle down a bit after things are back to normal. So here, because we're on a lag of 0, let's just see if we still are. Yep. I'm going to give myself the rest of the day off. So Alice over here can now handle all the work because we don't have a backlog. Except after a while, we will get a backlog building up. So we've got 2 already. So Alice is now 2 jobs behind. If this became like 10 jobs or something, then I might want to come back to work, and we might want something that tells us that. So what I'm going to aim to do in next week's show is we are going to build, this is sort of a view meter, it's just a stock graphic. But imagine we have like a stack of LEDs that we can sort of show a temperature gauge for like how far are we behind. And like the further behind we are, the more sort of worrying color that LEDs is. So, if we're at a low number of lag, we will be green, but we might have different levels of green. And then we might go to a sort of orange situation and then a red for, we're really quite behind. And those might trigger different alarms if we had a system to do that, or it might cause a process to automatically ramp things up. There's quite an interesting science in like how you do that as well, because if you get so far behind and you ramp things up and then you go below a threshold, do you take the extra person or the extra resource away immediately, or do you watch below that threshold for a certain time? So you don't get what I call sort of flapping, which is what happens when the thermostat reaches the temperature you set it to. Should it kick the heating in as soon as it goes below that, or should it let it drift a little bit and then kick it back in, so that you're not constantly like on off? Especially with people, you don't want to constantly like stand down, come back, stand down, come back. So we're going to build something that looks a little bit like one of these, and we're going to use one of these, which is it's actually very small, a 10-segment LED thing that basically each LED has a different color. So this doesn't necessarily relate too well to the actual colors of the ones that we got, but there's 10 different bars and 10 different colors, and you have to wire them up so that each LED operates independently. And then we'll have some code that says if the lag is a certain amount, for like every couple of jobs, we'll turn another LED on until we get to the maximum 10. And then you can imagine we might hook that up to a sort of if that then this type system that says, oh no, the lag is like, over this period, for this period of time, we should do something about it. But the aim next week is to basically just build a display with one of these. And slight spoiler alert, I have actually built one already, and you can sort of see it working away there. It's a little bit hard to see in the light, but you can see there's like red LEDs at one end, and there's some sort of, they're yellow, but they sort of diffuse as a sort of weird brown color. And then there's some greens, and then for some reason they put a blue one at the top. So I don't know why blue is like a better situation or not, but I've just got some test code running on a a Pi Pico there at the moment that is working with those LEDs. And as you can see, there's a lot of wiring required for that. Each LED is individual. So they each individually need to be wired to a pin on the Pico. And then they each need to be grounded, which is what that black wire towards the bottom is. And then they each need a resistor to basically stop us blowing the LEDs up with too much current. And then they needed diffusing so we could actually see them. So I stuck that's actually electrical tape stuck over the top of the LEDs there so that you've got a hope of seeing them. So what we're going to do in next week's show is we'll start from this point of we've got a hotel and we've got some staff and they're a consumer group and they are doing jobs. And we will work with something called Pico Redis, which is a tiny client for Redis for MicroPython, which is one of the languages that runs on the PyPico W there. And we'll connect to Redis and we will periodically say to it, hey, Xinfo groups, parse out the response that we get. We're going to be looking for that staff group. And then we'll build a visualization of that. And from there, you could sort of imagine that we build a sort of whole alarm system for, when we are behind on the work schedule, we need to do something, or somebody needs to know about it, or let's put more staff on. And we can watch it sort of decline over time. Tracking this sort of stuff, so like what your lag on the stream is, might be something interesting to use with, say, the time series functionality in Redis Stack as well. So you could store that over a number of days and then look at it and maybe do some forecasting and say, well, it looks like we always get really busy between like 10 and 11:30 when the breakfast service ends or something like that, and learn from that. But for now, we'll just use a point in time with an individual stream and we'll build this display next week. So yeah, that was about it for today's fun and games with IoT stuff. So I will just share the desktop again. And as I said earlier, the best place to chat with us about all things Redis is here on the Redis Discord. So you can go ahead and sign up for that here. It's at discord.gg/Redis. And that has channels for all sorts of things. So if you're interested in the IoT stuff, there is a Internet of Things channel down the bottom there. It looks like I've got a new message to go check out there. Come introduce yourself as a new member. That's the channel we're looking at now. And yeah, we'd love to hear what you're doing. So use self-promotion. If you've got a project or something that you're doing that's Redis related, we would be really interested in hearing from you. And yeah, that's about it for today. So if you want to see what else is going on this channel, then check out our schedule. So as I say, at the minute, I think it's myself streaming mostly Thursdays, Justin is Mondays, and Savannah on Tuesdays. So yeah, I will leave you in their capable hands, and I will aim to see you again next Thursday when we'll build the LED component of this project. All right, have a great rest of your day, and thanks for coming along. Bye.